Hello, Mr. Shand.
Hello, good night.
Good night. I'm trying to find out, did you send all the test papers to the relevant persons?
You didn't receive yours?
No, my name is Chanel Ewing and I did not receive mine.
All
However,
right.
I should say I'm not registered. I haven't paid my school fee as yet. So is that an issue in
Yes.
return in
Yeah.
receiving your paper?
Yeah, that would be the issue then. Yeah.
Or say
That would be
only
the
sent
issue.
to those who are fully registered?
That was the instruction. That was the instruction from the institution. But how soon can you sort it out? Because exams literally in another couple of weeks. You can sort it out soon?
Yeah, I will be dealing with it before the exam date.
No. Hold on. That's not what I'm asking. I want you to see the comments on the paper. Can you sort out something, say by the end of this week, even a portion of the payment by the end of this week?
I'll try, if not by the end of the month. So that should give me enough time to see the comment.
Okay, then, yeah, sure. But keep in touch with me, please.
Okay.
Yeah, good.
Sir, I'm expecting the session to be 2 hours. Was that the idea, or you're going more than 2 hours?
That was the idea. But as a just in case, I did it for 3 hours. As a just in case, should in case we're doing something, it doesn't. This is not the link that the college would have sent to us. So I don't want, in the midst of it all, it ends prematurely, if you see what I'm saying.
Oh, okay.
Yeah. So I did that as a caution. Yes, please.
Sir, I think you can disable the waiting list. Sir, I think you can disable the waiting room.
Oh, you're there for quite a while?
No, sir, no, sir.
Okay.
Internet isn't working that good, so it may drop off and come back in, and I'll be in the waiting room again. So that's what I'm just telling you.
Yeah. I don't know. It's all right. Yeah. I'll try and get it done. I know I was having a difficulty yesterday in my close-out meeting with my staff. That it was an issue again. I don't know what is happening, but sure, point taken. Or yeah, or maybe somebody who has stable internet connection could be my co-host if it doesn't work.
Yes, I have stable connection.
Great. So I'll make you co-host then, Terry. Thank you.
I think everyone is trying to reach home. That's why we'll have such.
Yeah, man. I feel good. So you understand my concern now that I really want to get in 2 solid hours. And this is why I asked the question. Funny story. I got up pretty early this morning because I had planned some house chores. And I was lingering in the bed and I said, no, let me send a message to the students. I said, no, Mr. Shan, I can't send a message them time during the morning. Not only that they will recognize that you don't sleep, but no, man. So when I sent the message out, what time you wanted to start class, I thought people were going to say 7 o'clock. But because I saw 3 persons said 6 o'clock, I said, okay, fine, 6 o'clock is fine.
Oh.
So yeah, so I didn't want to impose on you guys because I am at your mercy now, really. for the classes because my time has expired, if it's what I'm saying in terms of the semester. I'm just trying to give some makeup sessions. So that's why I asked a question. Normally, if it was on my schedule, I'd have said your class begins at this time. But because I'm at your mercy now, in setting up these classes, I asked.
But sir, good afternoon, good evening. But nobody objected to the 6th.
Which is the point I'm making though. And you're correct.
Yes, because if some persons, if I know if object to the 6th, that yes, they could object to the 6th. It's not like we had it in stone. You ask a question, some persons suggest something. So I think if persons have a difficulty, they could adjust.
Could have said 7 or so.
Yes.
We would have understood.
Yes.
Point well taken. Point well taken, because the truth is, after class, we gone back to do some, Christmas will come and you have one little food to something you want, do you want to move one little chest that drank dust behind it, getting the dust for a good while, don't you? Don't you know what I talk about?
Yes,
yeah, man. So you want to move behind the stove because chances are a piece of chicken leg would already drop around there and not even know. So yeah. So after class, I really wanted to just get back to doing some little stuff. But anyhow, since we're here, I'm gonna give the others maybe another 10 minutes. We'll start about 11 minutes. We'll start about 20 past. Whoever is here, we'll start at that time. But talk to me.
May I ask, what is the topic for this evening?
The plan is I need to do a refresher on the definite integrals. Let me just project what it is that I'm going to be doing. Share screen. Sometimes I wonder if I really have a life because I've been up trying to just decide what it is that I'm going to do with you guys. So I'm going to be doing, I did some stuff here with some definite integrals that I want to go through with you. Just, maybe not all of them, but just to do work 1 or 2 through with you, just to give a little refresher. And then maybe I give you a little one of them to do on your own. And then I want to look at the integral of some exponential functions. I did that with you already before, but I just want to just do a little refresher on that. And then after that one, I need to move into the substitution. So hopefully I can do those 3 things today, and that will be the end of what it is that I want to do. So those 3 things are areas that I want to look at. Do a little refresher on the definite integrals, and then I will do with you look at the integration of the exponential function. Did that in the introduction, but I want to do a 1 or 2 questions on that because I'm suspecting that you may get some of those questions on the multiple choice. Maybe not necessarily the essay type paper, but the multiple choice. And then on Thursday, God's willing. Remember we planned that we meet on Thursday. On Thursday, by the way, is it possible that we can meet early on Thursday? People them still let out people early on Thursday, or want to still leave out at the same 5 o'clock time at work?
So I guess we would have to send a voice note and ask in the class to be honest.
Round robin for me because round robin because I have committed myself for the Thursday class. For Thursday, Thursday would be the final teaching per se. So if I can finish all of those in good stead today, I can introduce to you the some differential equations. I need to look at differential equations. Let me just show you what I need to look at. I need to look at and have the documents open. Application of integration differentiation. Where it is. I think this is it. Right. New share. I have done the explicit differentiation with you already, but I just need to show you a little bit of the application here, how to find tangent and normal. In the event that they give you, I know you can do this stuff. And this is what it is that we're doing, applications of integration right here. But there is one little area that I need to look at. Other than that, oh Lord. Oh no, it's not on this one. So what it is that we're doing here now, what we've started, are questions like this, a definite integral. So I need to incorporate that, the diagram, should in case I give you a diagram, how you interpret the diagram for that. So we've done that. This part of it we've done already, in terms of the explicit differentiation. The explicit differentiation. There is, and a stationary point, oh crap. There is one thing though that, guys, I need to, where's that? Oh, I didn't open the document. Right. I just need to go through some L'Hopital's rule with you. I did this, prepare some stuff for you. And L'Hopital's rule is just really evaluating the limits of a function, but it is that we have to use differentiation. So L'Hopital's rule is not difficult. So if I finish those three things on time, I may just run into L'Hopital's rule. L'Hopital's is not difficult. And this is what I want to spend the time on Friday, Thursday. I want to spend the time looking at some first order differential equations. I want to spend a whole class, dedicate a whole class on this. And hear me out. It's not a difficult area, but students don't like it, in my opinion. And that's why I put it on for last. I put it for last so that it will be the freshest piece of information in your headspace. So I really want to do the differential equations last. When I touch differential equations, the only thing I'll do thereafter will be revisions and not teach you anything more. Because I'm sure you're going to get a differential equation, if not 1, 2. But students just don't like it. Students, every time I mark a paper, students either gloss over it. They pass the course still, but they gloss over it because they just don't want to do it. So trust me, we are moving in good steads. We should be able to finish this week, and then now use the time to do some, revision, some preparation, some well-deserved revisions. Anyhow, hope I answered the questions. I have 6 minutes to just have a quick conversation with you. As we just have 5 of you here, but no problem.
Okay, thank you for the overview of the expect.
No problem, Papa. I just want to have a quick conversation. Just lighten the class a little bit. Forgive me if anybody will feel offended by it, but life goes on. Is there anybody in the class at all that has a country experience with Christmas that you want to share with us? I mean, I don't come from the country, but if somebody could share like a country experience, say, boy, sir, Christmas morning, my granny used to get up and make hot chocolate tea and want to do with the chocolate. I don't know. It's just something. Anybody has any country experience you wanted us to share? Maybe not for the class, but for me, just throwing it out there. Anyone?
No, sir. But we just hear stories from mother.
What kind of stories?
They gather around together and play in the morning, and then they go back. Everything are prepared upon coal stove or wood, and dig dirt, them set the wood, the man them go out and get what them need to get from early in the morning. So after them come in now, them carry the food, give the woman or so, and them cut up everything, prepare up the meat. Normally them have them own poultry, like them would have them own cow, them would have them own goat or so chickens and so they would have clean that up from before. So it's not like say they may always have fridge as well. So them have to season up the meat well. The corn pork, like we have corn pork well seasoned. Then we have some other meats well seasoned as well, and put them in a container, have them put on from maybe a few days before. But the only reason why it was well seasoned and put in a container is because they never really have a fridge.
Right.
If no fridge,
but let me ask you though. No, but hold on. Let me ask you though. We have 3 minutes, but let me ask you though. So am I to extrapolate from what it is that you're saying now that people don't well season the stuff couple of days before now because we have a refrigerator now? That's what you're saying?
Well, yeah, it's not given as much time as it was before because the mere fact.
Go ahead, continue.
The mere fact that you have certain appliances that can hold the food for your time and you can just do it in the morning, you know. So it's I think it's better to prepare it from the day before, but some people just decide, oh, get up early in the morning and season it up and
no man,
right.
No man, Tariq, it's when you chop the bone,
Mm-hmm.
you're supposed to taste the seasoning on the bone for about 2 weeks worth of seasoning or 3 weeks worth of seasoning.
Yeah, mama, believe in that too.
Yes,
sure.
man. It's supposed to, you can't season it up the night before, man. I expect it's supposed to go right down in the bone. No, man. And especially if you're doing a pot roast, beef or pork, it have to have that sort of flavor. And guess what? It's one of the things is that country people, I don't know about them. Town people nowadays get up and start the cooking a Christmas dinner on Christmas Day.
Yeah.
But I'm of a firm belief that the Christmas dinner to start cook from the day before Christmas, so that it take it time. You know, go pressure no peas. You make the peas take it time and cooking at the coconut milk. When you do a pot roast, pork or chicken, because you can pot roast the chicken also. Well, the chicken is easy to pot roast, so you don't have to really worry about that. It's easier.
Sure.
But if you pot roasting your pork or your beef, you start that, you know, even the night before. You make it up on fire.
Not to put you, sir. Just to sum up what else we had to do. She said in country days there was more togetherness. So a lot of friends that weren't actually family came along and ate with the five for her in the country. But as you were talking about the season and so, but yeah.
Yeah, but guess what? Let me piggyback on what it is that you're just saying. Do you think in today's Christmas now that you have that level of togetherness that people will come together and, you know, like back then in the day for Christmas?
I can't see.
I don't know. For me, I
don't see it a lot. No.
I don't see it like the long time Christmas. I was saying to my team members in my meeting yesterday that in today's society, people talk about we're not supposed to be eating the batter. You know, when you make Christmas cake and you have like the one, so you have eggs and the something and you sit well. I don't know, but as a boy, I used to sit down under the table. I mean, not when the days that table wasn't mahogany like we have it now, our glass table, you know. Then the table at the table with the metal strip run at the corner. I don't know if you know what I talk about, but you have the table where you have the metal strip run at the corner on it, and then the table that can't done. You trap me upon it and it can't done. Then the table, there's a long-lasting table. And me sit down under the table, and as them turn them back for go for something, and me and my hand, the whole of my hand, you know, dipping at the bottom, and me under the table and I lick it off. And I'm saying to myself, never can I remember having any bouts of salmonella. And nowadays you hear, oh, eggs not supposed to be eaten raw because of salmonella and stuff. But in our days, we never used to worry about that. But nowadays, young people, them anyhow. You know, it's thanks for sharing, Papa. My only thing to you that I'll add to it is the reason for the season is not for ourselves. It is to
togetherness and sharing with others.
Absolutely. And also to remember the reason. Yes, Papa. You're gone.
About the cocoa. Never once, and like they must say, no, say it's a chocolate. I say, no man, this don't look like chocolate. This look like, you know, this can't be chocolate. And then take off the fruit off of your tree when it's yellow, and then open it and then get slimy stuff. And then you have to go dry it, and then you grate it, you put it on one cloth, and then you boil it, and then you make it settle. Cause you know, just make it boil and you throw it out, and then make it settle.
Yeah, man.
And then you might not see no steam and come out right now. But trust me, you see, if you just go and take a sip, it burn off the whole lip. So
and nowadays them don't serve it into the nowadays cup that is almost insulated.
Was
it is
enamel.
a white enamel cup with a blue ring around it. All right. So you have to sip, and when you're drinking tea, you know, you can't drink tea stush. You have to drink tea and sip it. Like if you touch with it, it will burn you. So you have to sip it. Yeah, man.
Yeah.
You have to sip that RS. And if you not have the chocolate, and you have to see the oil on top of it. Sorry, the oil on top of it. Something. Yeah, man. Them they call niceness. But we don't have that something again.
One big fact about Jamaica created chocolate milk. So that's great.
And the truth of the matter is, some of the finest grade of chocolate that you're eating, the Cadbury and the Symphony and the white chocolate, and, you know, incidentally, white chocolate, you know, that is milk powder then put in there, right? To color it from brown to white.
Oh, I never know that.
Yeah, man. So how it is that you get your white chocolate? So it depends. So you have different grades of white chocolate. So the white chocolate that tastes very smooth, they use high grade whitening. So they may not use milk powder, but of course it's a milk-based product that they use to get it from brown to white, because chocolate normally, chocolate is normally, you know, normally brown. So,
yeah.
So sometimes when you eat white chocolate, and a lot of people don't like the taste of white chocolate, it has a sort of milky taste because of the milk that I put in there in order to colorize it from brown to white. But yeah, thanks for sharing, Papa. I really hope that you guys have a good, you know, time, and, you know, the reason for the season is giving. Father God gave his son and to us, and we ought to be given to others as a replica of what it is that he has done. All right. As we continue, all right, let me start with example 4, no, example 11. As I said before, it's just a refresher. I'm not going to belabor the point because I really want to maximize. Good afternoon again. Evening now, students. I have just 8 of you, 9 of you here. I'm a firm believer where 2 or 3 are gathered, there he is in the midst, and he is in the midst now, and we are going to begin. We are going to continue. The aim of today is to go through 3 areas. 3 areas including the one that is projected. The one that is projected is something that we've done from before, so it shouldn't be difficult. So I'm just going to ask that you strike on your serious mode. Really and truly, we should end at 8 o'clock. I only did this as a just in case up to 9, but it's really up until 8. Let us see what can happen. All right. So when you're doing this integration, and I'll do this one as a refresher and then give you one to do depending on how well you guys do it. We will just we'll move quickly into the other areas that I need to look at. And incidentally, all the other areas that I'm going to be looking at today are areas that you already know. One is just showing a new method. Well, 2 of them is showing the new methods, but otherwise you should be able to answer those questions. But sometimes they may come specifically to say by using the substitution. It means that you have to use a substitution and can't do it otherwise. And it may say to you by using L'Hopital's rule. So if you found the limit, I know you guys know how to do limits. So if you found the limits using any other method other than L'Hopital's, if they say to you by using L'Hopital's rule, if you use any other method other than L'Hopital, you are going to be wrong. All right. So you have to be very purposeful in what it is that is being asked of you. All right, let's go. So the question asks, evaluate the integral x cubed plus 4x minus 5 dx for the limits 3, 2. Just reminding you that, remember, this is the upper limit up top, and this is the lower limit at the bottom. The upper limit will always be larger than the lower limit. There's no way you can have a 2 up here and a 3 down here. Won't be possible. All right. And then now we're going to be integrating as normal. Remember, when we're integrating, we're adding 1 to the power divided by the new power. So it's going to be x to the 4th over 4 plus 4x. This is going to be the second power over 2 minus 5x. You notice that I've dropped my integration sign, which is the elongated s, I have dropped the integration sign and I'm now putting it into parentheses and putting my upper limit and my lower limit. This line says to me that I have completed the integration process. I have completed integration, and of course we get marks for here. All I'm going to be doing now is evaluating the limits. It's the evaluation of the limits. Now that will take you into several steps. Now remember, you tell me now, why did I have this 2 times? Okay, so what I did was also reduce here, 2 into itself 1 time and 2 into 4 goes 2 times. So I now have x to the 4th over 4 plus 2x squared minus 5x for the limit 3, 2. Let me pause here. Are you okay so far?
Yes, sir.
Yes,
All right,
sir.
good, thanks. All right, remember, we're moving quickly now, so I'm going to ask, answer me. So thanks for answering. Also remember, it's upper limit minus the lower limit. It is the upper limit minus the lower limit. Always the upper limit minus the lower. So what you're going to do is, you're going to dump everything in the upper limit into the whole function. You're dunking everything into the whole function. Then you're going to subtract it by dunking everything into using the lower limit. All right. So in the upper limit, it's 3. That means anywhere in the whole of this integration, I see x. I'm going to put 3. Watch me. 3 to the 4th over 4 plus 2 times 3 squares minus 5 times 3 minus the same sort of function inside of yourself. I'm going to dunk the 2 inside of it. So I'm going to go down and say 2 to the 4th over 2 over 4 plus 2 times 2 squares minus 5 times 2. So once I would have substituted my limits into the functions, I am removing my upper limit and my lower limit. You notice I don't have them here because I've already done that operation. All that is left for me to do now is just to put it on my calculator and work with something. 3 to the 4th is 3 3 is 9. 9 9 is 81, so it will be 81 over 4. 3 squares is 9 times 2 is 18. Oh, I don't reach here so yet. Okay, let me kill 2 birds with 1 stone. So it's 2 times 9, 18. 5 times 3 is 15, so it's minus 15. So I reach right here, so 2 to the 4 is going to be 16, 16 over 4, boom, and 16 over 4 is 4. See it right there, so you notice I'm keeping my negative sign betwixt them nonetheless. 2 squares is 4, and 4 times 2 is 8. So the 8 right there, so. And 5 times negative 2 is going to be negative 10 right there, so. And then I'm going to say, oh, so what I did here was to say 81 over 4, and I keep it like that. And 18 minus 15 is going to be 3. For me, it's easier because I don't have 3 different numbers now to work with. And similarly, this one is quick and fast. 4 plus 8 is 12. And 12 minus 10 is 2. So this one is done. All I need to work on is right here. What I did was to find the LCM. And the LCM here is 4. And 4 into 4 goes 1 time, and 1 times 81 is 81. So I put by the 81 right here. There's an imaginary 1 under the 3. And 1 into 4 goes 4, and 4 times this 3 is 12. And 81 plus 12 is going to be 93. So I'm going to have 93 over 4 minus 2. And I think I found the LCM here just to show you what it is that is happening. LCM is 4. And 4 into 4 goes 1 time, and 1 times 93 is 93. Remember, any whole number can be written as a rational number. What is a rational number, sir? A fraction. So 1 into 4 goes 4 times, and 4 times negative 2 is negative 8. See there? Boom. And 93 minus 8 is going to be 85 over 4. And that's my answer. Remember always that you're going to write your unit squares. Any question?
Sir, can you do that last part again? The 93, the 93 and the 4 minus 2.
Right, so 93 minus 8 is going to be 82, and 82 plus 5. 93 minus, sorry, 90 minus 8 is 82, and 82 plus 3 is 85. So I'm going to have 85 over 4. If you want, you can convert it as from a mixed number or from an improper fraction to a mixed number. Or if you can leave it as 85 over 4. Of course, if you're doing a multiple choice, you may not see 85 over 4, but you may see 21 and a quarter. So if you put 21 and a quarter, 85 over 4, if you're doing an essay type question, you're good to go. You get the same number of marks. All right. Is that no, Joe?
Yes, sir.
All right, cool. Any questions from anybody else regarding what I just did?
Sorry, so for some reason, for some reason, if we get the answer like 85 over 4, I forgot to put the unit square. we're gonna lose a lot of mark for that.
You're going to lose a mark, yeah, because it is very important, Mikey. Very, very important about that you state your units. It's very important. So let's always remember, no, under exam conditions, you know, but yeah, always state your units. It's very important. Very, very important. Any other question?
No,
All
sir,
right.
I understand.
All right.
Sorry, can I scroll back up a little bit? Let me screenshot this. Yeah, scroll on, sir.
Tell me ready, Mikey.
You can go ahead, sir.
Okay. All right. I'm going to give you a question. I want you to try it on your own for me and see how far you can go to the question without my intervention.
Sir, if you're talking, you're very low.
Pretty easy. Pretty easy. Question number 12. If you're finished, don't sit there and wait. Just let me know when you're finished, please.
So you mean finish writing off the answer before or finish doing number 12?
Finish doing number 12, man.
Oh, okay. I misunderstood.
Okay, I'm seeing that response. So we'll talk to you. Very good. I want the rest of you. Remember, I want to go through some other stuff today here, guys, please. Okay, see that courage.
Here's my answer.
I actually missed it, but yes, I'm seeing it now. All right, so of the 3 responses that I got, 2 of them are the same, 1 different. So the score is 2-1 for now.
Good evening, sir.
I done.
Yes, sir. Just letting you know that I'm leaving from work now, so I can't really participate. I'm in commute.
Sure, same.
No problem. Who said that is the same? That's you, Joanna?
Yes, sir. I just reached home.
Okay, cool. No, you reach home. He's still in commute. All right, no problem. No problem, Papa.
Sir, I sent you my answer.
All right, so four responses so far. 3 of the responses are exact. 1 is off. Two more minutes, the rest of you. Don't want to rush you, but I'm anxious to see what it is that you know.
Sure, I sent you my answer, sir.
Who was it a while ago? Oh my, that was you?
Yes, sir.
I responded to you. I responded to you even before you said something. Check. Hello?
Yes, sir.
Yes, sir.
Yes,
Sir,
sir.
I'm listening.
Okay, because me away from the rest of one who not talk to me. All right, so the person who had a different answer, did some more work, double checked, and now got the correct answer. So 1, 2, 3, 4 out of 4. 4 out of 4. Sounding good, looking good.
Sir?
Sorry, I'm answering you, but I never recognized I was muted. Yeah, what's up?
I was just wondering, because I saw the long pause, I was just wondering what was happening.
Oh, no, man, I'm actually, the responses are coming to me as a direct message. So I'm responding to those direct messages.
Oh, okay.
All right. I'm going to project my answer. Thanks for the attempt. And congratulations to you all, the ones that have who got the answer. I'm going to encourage you to just look at the screen. All of you, even the ones who got the correct answer, look at the screen, see how I did the question, and see what you can do differently for it. Congratulations. For the most part, based on the responses I got, it seems as if you're following, you're understanding. Let me know when I can move. Matter of fact, you see, those of you who got the first question right, I bet you know, so they don't get this one right. I bet you know. And that is reverse psychology, incidentally. Do 13 for me, please, and we're moving on from there. Thank you. Don't be fooled by the first term in the question. Think of rearranging. Don't be fooled by it. Think of rearranging.
Sir, what did you say? That don't be fooled and think of rearranging?
Don't be fooled by the first term in the question. Think of rearranging. Wait, what keep? I'm not here for one of man. Remember,
Word the question.
We are where the question answer. Let's give
Right.
us 5 more minutes.
no, but we're not clear in the throat. No, someone knows in the dead man. Sure.
All right.
Got you.
Sir, in the meantime, sir, sir, could you go back at question 1, please? The first one that I think is 11,
First one.
number 11. I think it's number 11. Yes, sir. Could you explain the first stage? Because I don't really understand, sir.
Okay.
The first
And that's
step.
what I'm talking about, Mikey. That's what I want to know. On the clear in the throat, make me know so I did it. So if you know for something, talk to me, man. All right, let's go. So what it is that I'm doing here, this is my question. The question, there's nothing for me to rearrange. Nothing for me to rearrange right here because everything is standard. X cubed plus 4x plus minus 3. There's no fandangles with no division. None of those awkward looking stuff. So it means that I can go ahead and do my calculation. That's what I need to do. That's what I'm going to do. When I integrate, I add 1 to the power and divide by the new power. When I integrate, I add 1 to the power and divide by the new power. So my x cubed becomes x to the 4th over 4. My x cubed becomes x to the 4th over 4. My 4x becomes x squared over 2. And my negative 5 becomes negative 5x. Why? We're adding 1 to the power, divided by the new power. Adding 1 to the power, divided by the new power. We don't have a plus c because we have a definite integral. All I'm doing in this line is rearranging. I recognize that my 4x squared over 2 can be simplified as just 2x squared.
All right, sir. So I understand the x to the fourth over the fourth, but the 4x squared, how did we get the x squared right here?
There's an imaginary 1 over this x, Mikey.
Oh, okay. Yes, sir. Get it.
Yeah. So with that imaginary 1, we're going to add 1 to the power, divide by the new power. And then 1 to the power divided by the new power. So that's how we get it. Similar to this x, to the 5, negative 5. What we have there is x to the 0, because remember, anything raised to the power 0 is 1. So really I have x to the 0. So I'm going to add 1 to the power and divide by the new power. Tell me that you're good.
Yes, sir. I'm good now.
All right. If you're not good, Mike, don't say good or you're not good enough. Let me know.
No, sir, I'm good now. We just never understand the first line.
All right, fair enough, Papa. And then now, the integration would have ended. You notice that I don't have the integration sign anymore. But what I'm going to keep for now are my limits, because I've not yet applied the limits to the function. Always remember, it's the upper limit minus the lower limit. Always. Every single time. Upper minus lower. So for the upper limit, anywhere in the function I see x, I'm substituting the whole of the upper limit. See it yourself? 3 to the 4th over 4 plus 2 times 3 squared minus 5 times 3. When I do this substitution, I'm going to subtract the limit. It's always a negative sign betwixt them. You're always subtracting the lower limit from the upper limit. Always. And then all right, I soon respond to those 2 suggestions for the answer for this one. And then I'm going to do the same thing for the lower limit. Anywhere in the function I see x, I'm going to substitute the lower limit. All of it. All of it. So therefore, I'm going to have 2 to the 4th over 4 plus 2 times 2 squared minus 5 times 2. And then all I'm going to be doing is evaluating. All I'm going to be doing is evaluating. 3 to the 4th is going to be 81. So it's going to be 81 over 4 plus 2 times 3 squares is 9, 2 times 9, and minus 5 times 3. I just put it back right there. And then 2 to the 4th is going to be 16. So it's 16 over 4 plus 2 times 2 squared minus 5 times 2. And then this line is going to be 81 over 4. I can't break that down, so I'm just going to leave it as it is. 2 times 9, 18, put it here. And negative 5 times 3 is going to be negative 15. And then 2 to the 4th is 16. So that's 16 over 4. And 2 times 2 is 4 times 2 is 8. Well, I just put it at that. I just put back that there. So I'm going to have my 16 over 4, which is 4. I'm going to end up with my 8, and negative 2 times 5 is negative 10. I'm working this section first. 80 minus 15 is 3. Put it back here. Then I'm going to say, 81 plus 4. 81 over 4 plus 3. Minus 4 plus 2. 4 plus 8 is 12, and 12 minus 10 is 2. Finding the LCM here. Remember, this 3 is 3 over 1, always. You always have, once you see a whole number can be converted to a rational number. And a rational number is a fractional number. Always can convert to a rational number by dividing by 1. When I divide by 1, I'm not changing anything. When I divide by 1, I'm not changing anything. All right? So dividing by 1 gives me 3 over 1. And 1 into 4 goes 4 times 3 is 12. And of course, I carry out my 2. And then I'm going to end up with something looking like 81 plus 12 is 93 over 4 minus 2. And you know, you kind of dunk everything into a calculator here, or you can go and evaluate like what I'm doing right here now. Again, the LCM is 4. 4 into 4 goes 1 time, and 1 time is 93 is 93. Again, similar to this up here, this 2 is over 1. 1 into 4 goes 4 times, and 4 times negative 2 is negative 8. And then we say to ourselves, -93 minus 8 is 85. 93 minus 8 is equal to 85, and that's 85 over 4. Can't go any further. So I'm going to put it as 85 over 4 units squared. You can use unit square or you can use squared units. I'm seeing both variations coming into my answer. Whichever one suits you best, fine by me. Very good. Any clearer, Papa?
Yes, sir.
No problem. All right, so let me project that other one that I gave you. I got 7 over 6, I think, for the answer for, or 5 over 2. I got 5 over 2. Wait, nobody got the answer?
Sir, I don't know what I was doing, but it was
Lottie.
Sir, look at me.
Yes, Lottie, you're
It's the first part of the paper that you give us.
Say it again?
It's on the second sheet after the rules, the way you do that one.
Listen to me. Do what the song says, shine like a diamond, that's you. All right. All right, so the rest of you, I want you to look back at that question for me, please. Let me see. I'm going to go back up to the top. Now remember, 2 over x squared, which is why I'm saying to you, be careful. 2 over x squared is the same thing as 2x to the minus 2. Teacher? So I have to rearrange first. Let me not say anything more. Let me give you a chance to go through the question on your own. Wherever you're stuck, talk to me.
Oh, sir, after stopping at the second line, I started substituting there.
Oh no! So you never integrate at all, right?
Yeah, I integrated that. I got the -1 power over -1. That's where I stopped, and I started to supplement and substitute there.
Right here? Right here?
Yes.
What did we get the answer then?
Yeah, I don't know what I did wrong.
All right, check it and let me know. Because if you have that exact part, it clearly is a, I wonder if you have a negative sign problem, don't?
You may have a negative sign problem as well too.
Yeah, man. And I know you have that negative sign problem, Courage, from the last question you asked me when we had a face-to-face. So do me a favor, check to see if right here you ended up with a -2x to the -1 right here. And if it is that you carry this negative sign as -2 over x, chances are you carry it as +2 over x.
Yeah, when I did a supplement, when I substitute finish, I got -4 over -1. Yes.
X to the -1.
X to the -1.
So, teacher, you say you got the 2 here.
Yeah, I got that part. Yeah, then I substituted. When I put my 2 up there, that's 2 raised to power -1.
Did you get -1 when you put it in right here?
-1. I didn't put it like this. I didn't put it in a fraction way.
All right. Let me look up and compare yours. I'll stop it right there.
Like the 4th line there.
This right here.
Yeah, instead of -1, I had 4.
Courage, I'm going to beat you. Oh, you get 4, Courage. Oh man. All right. So maybe what I know what it did because I kind of see it. Because what it did here was to put the negative, was to put the 2 right here. I said 2 times 2 is 4. But remember, this is x to the negative 1. So this x actually belongs to the denominator.
Oh, okay.
Yeah, so I see it, right? You see what it is that you did?
Yes, sir. Yes, sir.
Okay, cool. All right, the rest of you look at it and let me know, please. Lotto, Jesus, shine like a diamond. Nice. The rest of you, I need to hear from you. Mikey, how you stay? Dane, Dan, you know, reach from yet? Chetty, Otto, how you stay?
Sir, still on the road. That's so rich.
What you say? It's very low. Shan, how you stay?
Sure, I said I'm still on the road.
Oh, you still on the road? All right, cool.
Well, sir, after I rearrange, I just got confused. So
Listen to me. I want all of you to listen carefully. I don't want anybody to be of the notion that the question is going to come as 2x squared minus 5x plus 6. Integrate between the limits 1 and 0. Hello? The man them going to give you something so you can apply the laws and the rules. So expect to get 2 over x minus the square root of x to the second power plus 2e to the 3x dx. So right there, Sunday, you have to go use the three different laws of the integration. So I want you to be very mindful of it. Don't go in there believing that it's going to be a straightforward sort of thing. Not it's there to confuse you, you know, but you have to be orthodox with the rules. That's the point I'm making.
okay.
Let me know when I can scroll. Okay, got you, Cherry. Give me half a second, please.
So you can scroll. Well, for my opinion, so if anybody else feel right. It looks like you can scroll in, sir. Sir?
So this is my step way.
Oh, all right, thanks.
Always stay.
Yes,
Sir.
so you can scroll.
Sir, can you explain like from the fourth line, go down, please?
From the fourth line.
Sir, where it have the -3 minus
Right, this?
-8 over- Yes, sir.
No problem. What type of calculator do you own, Joe?
Sir, a Casio.
Oh Lord, which of them, Joe?
Sir, I don't know how to describe it.
No, it's not described. It has a name, you know.
Sir,
Okay.
the SVPAM second edition, something like that.
Okay, so that means you have the ABC button to it.
Yes, sir.
All right, so work with me now. I'm going to help you to evaluate this, all of this one time. You follow my screen?
Sir.
Talk to me now.
Sir, yes, yes.
Oh, okay, well, I didn't hear you say yes. I just hear you say sir. All right. So use your calculator for me now. Work with me. Press -2.
Yes, sir.
Plus. 5. ABC2.
Oh.
-6. And come out to get.
Sir, -5
11.
and 1/2, so 11/2.
Very good. But do me a favor. Do me a favor. Don't touch the calculator, you know. Press second function, ABC. And you should get -11/2 right here, don't?
Yes, sir.
Yeah, man.
Sir, well, I'm not alive. Me get -5.5.
Press F to D then. F to D or S to D.
Okay.
It's the same answer, no? 11/2 is the same. -11/2 is the same as 5.5, but I want you to get the improper.
Okay. Can I get it?
You get it now? Yeah, man.
Sir.
I'll come to you, honey. So you can't get the question wrong, you know, because you have a calculator that can be used to work it.
Sir, because we see you have the -8/1, I'm realize how you get it. The 6 and the
-2
2.
times -2 -6 is -8.
Sir, that I realize. Yeah.
Teddy, your turn.
Oh, you answered my question a while ago.
Yeah, man.
The -2, because that's what I was saying, because I'm always entering it in my calculator and it jump go all the way. We don't know the answer there down here. So all of them is say, oh sir, how did that work? So you just not get my question answered.
There's a method to my madness. What I try to do is put
I can't find ABC on my calculator.
Is it that you have a cheap one? Haha, joking.
No.
Which one you have?
I have the same one that you tell me to buy, FX-991EX.
Okay. Lord Jesus, I show up on me, you know. You sound like you have the upper version one. All right, do me a favor. Does it say natural display written in the middle of the calculator, Doctor?
Not what, sir?
Natural display.
Natural display.
No?
No. Yes, sir.
Do me a favor. Take a pic.
Take a picture?
And put it in the group for me, please. Yeah.
Sir, my one of the same calculator like that, but my one said natural-v.pam.
Yeah, man.
Second edition.
Maybe I'm gonna see then.
Yeah, man. It's a good calculator. So that is the upper version to what Joe has. All right, when you send it, I will reference I'll walk you through.
Sensor.
Yeah, man, I'm seeing it now. Yeah, man, I figured as much. All right. So it's on the OPT, that is going to be your, how you not see natural display? Oh, so them look like them leave off natural display on your one. This incidentally is a good calculator, you know.
If me can use it, because it have a function there, the of X at the top.
Absolutely. And I will show you how to. I will show you how to, so you can use the double check your answer. And that's why you must listen to your teacher when the teacher speak. Get one decent calculator that you can use. This one is good to go. All right, do me a favor, no, I'm not up.
Yes,
sir. You see under the OPT, the option.
Yes, sir.
You're going to have a fraction. So you see that thing with the solid rectangle and the open open rectangle on the bottom?
Yes, sir.
That is your division button. So work with me now. Clear your calculator, press 2. Sorry, -2.
-2.
Then you can press plus.
Yes, sir.
Then you can press the division button, the fraction button. And you're supposed to say a fraction come up on the calculator now with numerator and denominator, don't?
Yes, sir.
Good. Is the cursor in the top part of it?
Yes, sir.
All right, press 5.
Yes, sir.
Use, you see them
yes,
four
sir.
symbols?
I figured that out.
Good. So you go down and put in the 2.
Yes, sir. Click it out now.
Yeah, man, you have to go use the right button now to come out of it. And then press -6. And tell me what you get.
-11/2.
Magic.
Magic. Same way my one right to say.
Magic.
Very nice.
Where did you buy a calculator?
Online, we buy mine.
Online, I bought mine too.
All right, let me just show you. Oh, come on, Mr. Shand. I'm hungry. Jeez, I'm father. All right, let's go. That's not the question. All right, let me help you with something. All right, so auto and lotto. By the way, anybody else has a calculator similar to this? That was in that lotto place in the group?
Oh, sir. Sir, when I put mine in the calculator, in my calculator, it didn't give me that. Give me a -5.5.
Same difference. Same answer.
That's enough for me.
All right. Oh Lord, I don't even have an emulator for that one, so I can show it. All right, do me a favor. Let me just show you a function of this thing here that you can use to double check. It won't show you the steps, but you can use it to double check your answer. The pair of you, auto and lotto. I'm gonna walk you through something. It's a pity I don't have an emulator of this 99EX. But let me show you because it's important for me to take some time out to teach you how to use a calculator. You see the integration sign that is to the right of it on the menu setup?
Yes, sir.
All right, I want you to press it for me.
Yes, sir.
I want to open your parentheses. Let me know when you open your parentheses.
I will that then now, sir.
The brackets, the bracket. Beside ENG.
Okay, I find it.
Open it, good. Then you are going to press the ABC button.
Remember, I don't have mine, so I have to do the
Sorry,
fraction.
yeah. You know what I mean? The fraction button. Press the fraction.
Yes, sir.
Press 2 in the numerator.
Yes, sir.
Go to the denominator using the cursor.
Yes, sir.
All right, then look to the top of the calculator, say alpha. The very top, it says it's a shift then alpha.
Yes, sir. I say alpha. Yes, sir.
All right, press alpha.
Yes, sir.
You see it's the close sign for the parentheses.
Yes,
above it,
sir.
you see a red X.
Yes, sir.
Press the close sign for the parentheses.
Yes, sir.
What is it come up on the calculator now?
X, sir.
Very good. And then now, look in, it's the way you put the fraction button, 2 buttons away from that, when you say X squared.
Yes, sir.
Press the square for me and tell me if it come up to be X squared now.
Yes, sir.
All right. Use the right from your oh goodness, let me call it again.
Come off alpha now, sir.
No man, the control, the 4 little something in the middle. Your control panel right there. That's not what they call it, but that's what I'll tell you.
Yes,
Go
sir.
to the right of it and then click plus. Navigation button.
Yes.
Plus 5, and then press alpha X again to get the 5X.
Yes, sir.
And then press -6.
Yes, sir.
Close the parentheses.
Yes, sir.
Use your right navigation button now and press it and tell me if you see it blinking under the lower limit.
No, sir. Pass it.
All right. Continue pressing until you get it into the limit button, limit slots.
Yes, sir. It's there now, and that the lower one.
All right, put in 1.
Yes,
Press
sir.
press the up button to get it to the upper limit.
Yes, sir. It's there.
Put in 2.
Yes, sir.
Press equal.
5/2.
You get 5/2?
Yes, sir.
And what's my answer?
5/2.
Magic.
But for YouTube is to find out how to use it.
Yeah, man, magic, right? So, so you're going to the exam and you do a question like this. Remember now that your method, your steps will be shown, because as I said before, you get marks for your steps. But the point is, if you can go into the exam and do your stuff, and then put in a function and double check to see that boy, say answer right, and you have your steps. Mr. Shan can't take off no mark out of the something unless you leave off a unit square. I know say never say 5/2 unit square.
Yeah,
for the
unit
calculator.
square.
Right. So you can use it as just to double check your stuff. These are what these engineers and land surveyors and quantity surveyors and whoever it is, will have on their person when they're going to do the stuff, because them don't have pen and paper for go do them long calculation here. Them just put in function, boof, buff, get what answer and tell you what it is. All right, and they're having computer stuff. I would have shown you my emulator, but my emulator is expired.
Yeah, we need to go back to the question. I should try to figure it out so I can put it in.
Yeah, coming on. Yeah, I'm just trying a thing right here. So, oh, I see something here now. All right, so auto and yours are the same, except that auto one is a plus. What is the difference between the plus now? I'm not seeing a difference. Oh, yes. No, I'm not seeing a difference. Because you have the calc. Oh, so lot of one have the option button. You don't have the option button, but you have all the others. Yeah, pretty much the same thing. Yeah, pretty much the same thing. Yeah. All right. Sorry. You said that you want me to go up, Otto?
Yeah, man, try still I can't figure out how to put it in by myself.
All right. Let me.
So where you find the cube?
The cube. So you're
It's
not going to
over
find
the
a
x
cube.
squared. That's over x
Right.
squared.
So you're not going to find a cube. So what you have to do is press the. Let me go back and look at the calculator.
That's mine with x is over here. X squared is over x cube in.
All right. No, you're not going
You
to
can't use shift.
No, can't use shift. Look beside the x squared. Look to the right of the x squared button.
Oh,
You see what with that x with a box?
Yes, sir.
All right, so just press the x with that box, and then you can put in any number there. So you can get x squared, x to the fourth, x to the half, x to anything.
Oh,
yeah. Yeah.
Right. That's where you can do the stuff.
Right.
Also, what I'll do is I'll write out the algorithm. I'm going to move on, but I'll write out the algorithm, Otto, and send it out here so you can look at it to practice it on your own.
No problem.
All right, cool.
All right, thank you.
No problem.
Thank you, sir.
No problem.
Wait on them, sir, to check it out.
Yeah. All right, whereby no, I'm at Zoom. All right. So the rest of you, we would have done that and would have gotten our answer. All right. I'm going to move. I have to move because we say 8 o'clock and it's fast approaching. Let me just spend some time on this. If I can't do this one, I'll just I said 3, but it's all right. Lord, hold on. All right, Father, which one I should do? This is not difficult, do you know? I could just go through this because it's not difficult. And then, all right. Okay, guys, so I have 20 minutes, 10 minutes each on this stuff. And 10 minutes each, and then we, trust me, when I say it's not difficult, it's not difficult. 10 minutes each. Integration of the exponential functions. I am speaking to this in particular to your multiple choice questions. I doubt that I'm going to give you a, what do they do? I doubt that they will give you an exponential function. Well, maybe, because some of the past papers, we may have found.
Yes, sir, I think I see.
1 or 2. It's not a whole lot of them, don't?
No, sir. No, sir.
Right. So let me go. I have to, just in case them let them head and put in one in there. The rules are not different. I colorize them so you can see exactly what is happening. Only 2 of them. It says the integral of e to the ax dx. The integral of e to the ax dx. Remember, sir said in the rule, the integral of the exponential function is the exponential function itself. So you're going to see e to the ax in the answer. See here? E to the ax in the answer plus the c. Why plus c? Because it's an indefinite integral. But remember, sir, say you're going to look at the power, you're going to differentiate the power and then reciprocate. When you differentiate ax, what do you get? Say a.
A.
Right, a.
A.
Good. And then when you reciprocate a, what do you get? So 1 over a.
1 over a.
Mm-hmm. 1 over a e to the ax. Remember, we did this in class, you know. We did this. So, which is why I'm saying it's not difficult. We've done this before. So it says to differentiate the function and then reciprocating it times the given exponential function plus c. So we can differentiate the function and then reciprocating it times the given exponential function plus c. You can differentiate the function. The function is up top here, so, all right? And then reciprocating it 1 over the answer times the given exponential function, because the differential of the exponential function is the exponential function itself plus c. All right. Now, in blue, let me just explain what is happening in between, what is here. In the middle of it, what you're going to be doing, you're going to find the natural logarithm of E. So when you're integrating this, you're actually finding, you're reciprocating the stuff, but you're also finding a natural logarithm, which is ln E. And if you press ln E on your calculator, you're going to get 1. See it out here, so? I said to you that ln E is equal to 1. ln E is equals to 1. So what you really have is 1 over A times ln E, but ln E is 1, and 1 times A is A. And then E to the AX plus C is this. So I just put this here in blue to show you the intermediate stage. But guess what? At this point, you don't have to know the intermediate stage. You know from your so over to here so. But this is what is happening. ln E is equals to 1. Importantly, I'm telling you about ln E being equals to 1 as a just in case. You're going to the exam and you see them talk about ln E. None of the class say, sir, never introduced us to ln E before. All right? Watch me now. So this one you already knew from before. True or false?
True, sir.
I gave it this at the very first, the start of the integration. This is one of the laws I wrote down on the integration paper. This one here now is a little different. And I want you to pay special attention to this one. The integral of A B to the X. What's the difference, sir? You notice here, that is an exponential function raised to a power. It is E raised to something. But the one here now is a natural number. They say A is greater than 0. And A is not equals to 1. So 2, 3, 4, 5, 6, 7, 8, 9, yeah? A is a whole number greater than 0, but not equals to 1. So when you have a number being raised to a power, this is what you must do. You're going to still do the same thing like we did before. It is still exponential in by nature. So it's going to be A to the BX, C to your so A to the BX plus C because it's a indefinite integral. But you are going to also differentiate the power. And the differential of BX is going to be B. So it's going to be 1 over B. But you're going to find the natural logarithm of A, ln A. See here? Ln of whatever is the base. Ln of the base. This is a base and this is a power, you know. A is a base, this is a power. E is a base, and that's the power. So I'm still finding the logarithm of E, the base, but it so happened that ln E is 1. But in this case, ln A is not 1 because it's not an exponential function. So, which is why I put this in here, because if you know this inside piece here, it means that you'll know this one also. So let me go again. For this one, number 1, when we're integrating E to the AX dx, we are going to, the integral of an exponential function is the exponential function itself. So I'm going to have as part of my answer E to the AX. And because it's an indefinite integral, I'm going to have plus C. See here? E raised to the AX plus C. How do I treat the other part now? I'm going to differentiate the power and reciprocate it. When I differentiate the power and reciprocate it, I'm going to have 1 over A. But now I must multiply the denominator by the ln of this base, ln E. But ln E is 1. So I can just safely write 1 over A, E to the AX plus C. See it right here, so? But in a case like this, where the base is not E, I have to maintain my 1 over B ln A. The same thing like I did up here is the same thing here. It's just that 1 is E, 1 is a number, greater than 0 and not equals to 1. So differentiate the function and take ln of the base, then reciprocating both of them, and finally times it by the given exponential function plus C. Watch me. I'm integrating e to the 2x dx. Remember, this here is the base, but ln e is 1, so I don't have to write any ln because ln e is 1. So I'm going to end up with my e to the 2x in my final answer plus c. Then I'm going to differentiate the power. The differential of 2x is 2. Reciprocate it, I get 1 over 2 e to the 2x plus c. Tell me that you see this.
Yes, sir.
Yes, sir.
All right. You know, work with what answer me now? Uh-oh, sir. You say, what a man stays about? Him here one easy one for the example and look on the other one now. Not a problem. Because I'm integrating the exponential of e to the x squared plus 5x plus 2. What sir said? You're going to differentiate the function. When you differentiate x squared plus 5x plus 2, what do you get?
Sir, 1 over
X
x
plus 5.
cubed.
No. We never say integrate, we say differentiate.
Sir, where's just a rest?
Good. When I differentiate x squared plus 5x plus 2, what do I get?
Sir, x cubed.
Joe. And you come up with the same x cube.
Sir, my
I'm
bad.
differentiating. Hold on a
X
minute.
plus 5.
Hold on.
Sir?
So I said if Bill back give him 5.
Sorry about that. Heard some strange noises outside, so I had to go and play detective. All right, let's go. All right. So what is the differential again of x squared plus 5x plus 2? Okay.
2x plus 5.
2x plus 5, thanks. What do I do with that 2x plus 5?
Sir, you reciprocate it.
Good, so I'm gonna get what?
1 over 2x plus 5.
Very good. It's gonna be 1 over 2x plus 5 e to the x squared. Tell me say that hard now, no?
Sir, not hard yet.
And it's not gonna be hard. This is it. I promise you. All right, 1 for the road, and then we'll move to the other example.
Sir, so that's just it.
All right, yeah. All right, so let me just say, yeah, that's it, honey.
This
That's
is
it.
what I'm talking about.
No. Explain to me what the power there is. What? Read the power for me, please.
Sir, x minus 1 over x plus 1.
How do you differentiate that? By what rule?
Quotient?
Quotient rule.
Quotient.
Quotient rule, yeah. Have I taught you the quotient rule?
Yes, sir.
Yeah, man. So it can't hard. Let me say, don't remember how to do the quotient rule, but it can't hard. Right? So in the interest of time, I'm going to just go through the quotient rule right here as a refresher, but it is not difficult. So you're going to let y be equals to the function, just this function. Then you're going to differentiate it, the denominator, see it here, x plus 1, see it right here, so boom. Times the differentiation of the numerator. When you differentiate the numerator, you're going to get 1 minus the numerator, minus x minus 1, times the differentiation of the denominator. When you differentiate the denominator, you get 1 all over the denominator squares. I'm sure, positive even, that this was one of the first things that we did. And that's why I'm just refreshing your memory. So this is not difficult because we already know how to do this step. Then no, we're going to simplify. This is a 1. It's not raised to a power greater than 1. So we're going to expand. 1 times x plus 1 is x plus 1. See here, x plus 1. And this is 1 times x minus 1 is x minus 1, but that is being multiplied by another negative sign. So it's going to be negative x plus 1. See here, negative x plus 1. And the x is cancelled out. So I'm just going to have 2 over x plus 1 all squares. So my differential is going to be 2 over x plus 1 all squares. You know how to do this already. The aim in teaching you this topic is not to teach you this because I've taught you this before. All right? Then no. So this is where I'm going to pick up. To do this, it's going to be 1 over this. Blow out. 1 over a fraction. It means that you're going to be inverting and multiply. Talk truth.
Yes, sir.
Good. So what we have now is going to be x plus 1 all squared over 2. So I'm expecting my answer to be no, because what you're going to have here is 1 over 2 divided by x plus 1 all squared. So that's going to invert, multiply. So it becomes x plus 1 all squared over 2 e to the x minus 1 over x plus 1 plus c. See there? You just invert the differential and write back the whole function that them give you up here, so plus c because it's an indefinite integral, and you're good to go. You honestly tell me no. Say that hard. Me want you seriously. In your spirit, you feel it in your bones, say, Sir never did teach with all of the. So you go through this way too quick. I'm gonna have to examine another couple of weeks. Me do this long time. So me just interested in this answer. All I'm showing you that 1 divided by 2 over x plus 1 all square, you are going to just flip in these two. So it's going to become x plus 1 all square over 2. See here? X plus 1 all square over 2. You write back the exponential function because when you're integrating an exponential function, it is the exponential function itself times the reciprocal of the differential. And then is my plus c. Done.
Done.
All right. One more, but I want to give you one now where it's, all right, since I have that there, talk it out. What's the answer for this? Just talk it out quick and fast.
Sir,
1 over 2x
times e raised to the power x
Squared minus 7.
minus 7.
Excellent. All right, I'm going to press pause here because I'm not teach way too long for notes. Say, me not hear from Kamoy. Me not hear from Chedi. Chedi, I don't know if you reach home yet. Oh, Christopher decided to join us. I'm not hearing from Christopher. Dan, I'm not hearing from you. You know, reach from it, Daniel. Dane, I'm not hearing from you. Tariq, you look like you're going to sleep, Papa. You were awake earlier on in class. Rajay is awake.
Sir, no, sleep. Just I take time and try and understand what's going on.
Shani, you're not talking to me. You're only talking to me one time.
Sir, are you trying to some of this? I try follow.
All right, Papa. Come on, man.
What's up in your answer me?
Jesus, Father. You see, when hey, sir, can't only do 2 things at a time and not check the chat and eat. All right, hold on. Coming to you, Papa. Let me just. How many seen a WhatsApp from long time?
Sent one yesterday and today. Well, no, from Sunday and today.
Oh, yeah, I see it. Yeah, I see it. Okay, no problem. I will action those for you.
Thanks.
Yeah, man, easy, Papa. Is Sovan back with us? I know he was here and then got kicked off. Sovan, are you here? No. Sovan was here and he got kicked off. All right. So very good. Very good to know that you
Sir,
guys...
before you leave, I want to show you something when class ends, sir.
No problem, buddy. No problem. All right, you then say to me, say, oh, sir, no, you know, see one here? Then, sir, you expect me if we're going to exam and see the integral of 2 raised to the 5x and expect me to do it?
1
Why
over
not?
5. Oh, never mind.
No. Continue. You start to continue. You can't back out now. You start already. 1 over 5 what?
Sir, because I never see the E beside it.
What you say? 1 over 5 what?
Sir, 1 over 5, 2 to the 5x plus c.
Is she correct?
Sir, that's what I was going to say.
Is she correct?
Sir, I don't know.
May I hear what you said?
No.
She said 1 over 5. She said 1 over 5, 2 to the 5x plus c. Is she correct?
No, sir.
I think
you have to do the log
for this one.
name of
Yeah, the
2.
second rule, sir.
Right. You have to put ln2 because this is not e. The only way we get rid of this is now because ln is 1.
I wasn't correct, but you continue.
Me never asked if it is correct. Me just want to see if you remember. So you have to put the ln2. So you're almost right. I'll give you, if it's a 2 mark, I'll give you 1 mark. So you're not fully wrong. Everybody see number 5?
Yes, sir.
All right.
Yes, sir.
All right. Come on. All right, Papa. We say I've been setting up, you see. So when I get one different teacher for calculus 2, so that
no, sir, not the way that.
He said, hold on, the man.
Sir, mad. So what did you do? Did you drink some alcohol?
Matter of fact, I'm tempted to. I'm tempted to have some stone ginger wine after this class. But I will tell you, I want to find a lecturer from the university. So when the lecturer said, okay, fine, the lecturer up there and ask you to understand, you know. The lecturer put it on the board and go through 1 or 2 questions, right? So if you not catch it, you better raise your hand and say, sir, XYZ, and then he may say to you, or she may say to you, ask the questions in the tutorial sessions. So when you go to the lecture, you know, if it's true, nobody don't want nobody shame them in the class, them don't talk. Excelsior is different from that sort of experience. When you go into one of the lecturers on campus, it's as if you drop a pin, sometimes you can hear it because nobody now asks the lecturer nothing. Everybody's just interested to see what the lecturer is saying and writing it off the board because you have to go to the tutorial sessions now where we have the talkie. You hear me session say it? Are you understanding? And go through the register and call names. And sometimes when it's still not responding. Say it again.
I was just gonna say they're not gonna do that. I always say one of the things I like about the Excelsior teacher, they teach different from other lecturers because most of where you have to go do your own research and do what you have to do. And I get the baby spoon feed.
I'm going to tell you, and I keep telling you guys in the auto, you will have a conversation with the lecturer's class that you have now. And the lecturer will know that you're in the class, and the lecturer will stop and have the conversation with you. And the lecturer will continue walking to the class, and you go into the opposite direction. You think the lecturer will say, oh, do you have a class with me now? No. Oh, no. But guess what? Just Excelsior has it, you know, but we don't enforce it really. We have an 85% rule that if you don't come to 85% of the classes, we can block you. When I say we, the lecturer can block you from doing the exam. Literally block you. Check your handbook. Check your handbook. And I'm telling you what will happen at the university is that when you go in for go to the exam, the invigilators have your information there. So when they come and they check, because what the lecturers will do is give the invigilation, the chief invigilator, Mark Shand, ID number 2021, 2020. You see when Mark Shand sit down and them take your ID and them start to record the stuff and them recognize, oh, he's in here. The chief is going to come to you and say, sir, you are disqualified from doing the exam as per the 85% rule. We're asking you to leave the exam room. And if you decide to you not leave the exam room, the invigilator going to fight you. I'm going to say, okay. And you're going to sit down and you're going to do the paper. But guess what will happen after? It now mark. It's not going to be marked. Excelsior has that rule. Excelsior has that rule, you know. Check your handbook. But people don't come to class and people say, is my money paying? Okay. Be different. But some of you don't recognize. Go to the name brands and you'll see this sort of treatment. You see, if you have your master's degree and you're found cheating while doing your PhD, the university can rescind your master's, rescind your bachelor's, and if you did do an associate degree, it rescind also. What the word rescind mean? It means they take away. And even if you still have the paper, what do you mean? If you still have the paper and say, well, when I can't claim so I take it, me still have my degree hung up in my house. You see, when you go for your new job, why didn't them ask you for transcript? Why didn't them ask you for transcript? So if you decide to you're going to migrate and go foreign, and you want to move into a big job and they say, oh, we're going to ask you to provide transcript from your institution. The universities, when they say that student found cheating and degrees are null and void, so it means they don't have no degree, you can't use it. It's just like a nurse or a doctor that has a medical degree and can't practice because they've lost their license. It's just like a lawyer who went to the bar and is like an attorney at law. Is no longer an attorney, is now a lawyer because they can't practice law. So when you practice law, you're an attorney. So you're only now a lawyer, a degree holder of a LLB. So be careful. You see me talk to you about cheating? Be careful, because these are things that are in place. All right. Let's go. You are being warned. Yeah, let me just give you this one and then we'll move on. Oh, Jesus, 806. Let's go. The integral of 3 raised to the 2x squared minus x plus 3. 3 raised to the 2x squared minus x plus 3. I've given you 1 minute to write your answer down, and then I am gonna call upon somebody to answer me. It could be any of the 12 of you that are here. No, man. Hold on there. Hold on there. All right. Anybody with the answer yet?
Yes, sir.
Nice job. What do you get for your answer, Courage?
I sent mine in the chat.
Okay.
So I think you understand that, but yeah.
I'm gonna say yes, Tariq. That's the word. We call it now.
No.
Blacklisted. Oh, no, I was about I never talked to Tariq, but I say incorrect though.
Sir, but just sir,
Anyhow, I never said to Tariq, and it's because I said Tariq's response. I didn't want to respond to you first before I respond to Tariq. They say anyhow. I never respond to Tariq and say yes, Tariq, but blacklisted is a word. I would have said to you, Joe, you're wrong. You have to put your plus C. Courage, tell us what you get for your answer, hon.
1/4x minus 1 times ln3. Yeah, oh yeah, that's
What you have. Good job. Good job. No, let me tell you something. When somebody give you a question like this, and you sit down and you work it, them supposed to say, blow in brighty or she brighty. What a easy something this. You know the rules, easy something, easy 1, 2, 3 something. Easy something, you know. Just do the something, man. Let me stop and ask a question. Is there anyone in the class struggling with these? Because I'm moving on after the other example. Anybody struggling and you want me to go through?
Sir, I think I need to recap in order to.
You're very low, Dan.
Sir, you hear me now?
Oh, Lord. All right, talk. Maybe somebody can translate.
Okay. All right, sir.
Is it just me that he comes across low, or is low for everybody?
It's very low.
Okay,
Not
very
here.
low. Dan. Very low. Type it. You still in commute?
Yes, I am, sir. Not going
Rocks
to
in a
reach home
country
for
live?
now. No, man, in Portmore. I'm just on the road doing some stuff.
Oh, so you have all of the money them create traffic on the road because you're shopping. All right. See if you can shout it. Shout it and let me hear your question.
All right, sir. So when you have a whole number and you don't have the e, so a whole number is raised to the power of something. Does that mean that only that you have the logarithmic
The ln of that number. The ln of the base. Yes, sir.
Okay. And you still, if it's an indefinite function, you still
have a plus C.
have the whole function.
Yes, sir. Yes, sir.
All right, respect, sir.
That's up. Any other questions?
Yes, sir.
Go ahead.
Sir, You can go over the number 6, please. You can go through it for me, please.
No problem. No problem, honey. All right. Sorry, I'm responding to something. You see, when you don't ask me to. All right. So what I'm saying to you, Teddy, is that just like what Dan asked a while ago, once you have a whole number as the base, you have to include the logarithm of that number, the ln of that number. So it's going to be just like we did before, 1 over the reciprocal or 1 over the differential of the power. But once here is a whole number, we have to put ln of that number. Once it is e as the base, we don't have to put anything there, any ln. Why, sir? Because we're going to put ln e. But what's the value of ln e? The value of ln e is 1. The value of ln e is 1. And if you don't believe me, you don't believe me, you don't believe me, I will ask Lotto and Auto to confirm it. Take out your good calculators, please, guys. Matter of fact, Joe, your calculator is supposed to be able to do it also. Take out your calculators, all of you. Look at your calculators and tell me if you can find the ln function. Do you see ln? It's nobody beside log.
Yes, sir.
All right. You can press ln.
Yes, sir.
And then you're gonna press, oh Lord, let me go back to yours, Lotto, and see if I can find I'm just trying to find where yours is. Oh Lord, I'm not seeing it, but I know it's there, you know.
What you looking for, sir?
Then you can press alpha, and then you can press E. Whenever you press alpha is in the color red. Look on the keyboard for the red stuff. So you can press E. And then now you can have ln E on your calculator, and then you press equal and what answer you get. Your E is at the bottom beside to the left of the answer something.
ln alpha.
E and then equal.
Oh. Red E?
Yeah.
Is it that E over the cost? That one?
E over the cost?
Or is that not the one yet? Oh,
no.
Way at the bottom.
At the bottom, way bottom.
Where you have 10x.
Yeah, 10 to the x, yeah.
10x, yeah. Yes, sir.
And press equal until when you get
1.
1.
1, sir.
Okay. Wow. So that means I was right.
Oh,
yeah, man. Magic.
So can we put the thing in it? The entire question?
No. I'm going to tell you why. The calculator, this calculator is only programmable for definite integrals and not indefinite ones.
Okay.
Yeah.
So I sent the calculator I'm using to the group.
Okay.
But I wasn't seeing some of the functions you were talking about.
Okay. Yeah, me not see it either. Courage.
Yeah, one. So you have one app with name Symbol App. I don't even know it.
Those apps are illegal here. We not use them something there. When I say that, sometimes they give you things that are not necessarily how it is.
This one with Terry.
We're Terry.
I cannot do it.
No.
Laughter is better than anything.
Terry.
My gosh.
You know,
take your picture and send it, Terry.
Terry.
Game Boy.
Terry.
Yeah, man.
Terry.
Oh my God.
Terry.
Terry,
you know, say when I go to school, you know, me follow company. I know I was born a leader, but I follow company and go game shop. And you know, Tariq, you see the big plus button in the middle. You know, when you play Pac-Man.
Yeah.
You know, when you play Pac-Man, right?
Yeah, man, remember what Pac-Man.
Yeah, man. And then we have a little button on the side. So when you want him for turn one, I just press it and you move the joystick in the middle. That's the same as it looks.
Exactly.
Same as it looks. Courage, we love you. But
always do.
But Courage, Courage, where you get this calculator, Courage?
Africa.
Actually, so it's the calculator they give to every student writing CSEC, and Nigeria will call it WAEC.
So this is one from Nigeria.
Yeah.
Okay, all right. So
you
guess what?
Oh my gosh.
Courage did very well with her calculator. Leave Courage calculator alone. But Courage, me can't help you that one. You're still here. Because
okay.
you're not gonna see the something them on this one. All right, no, you should be able to. Come on, hold on. I am just not seeing it. Okay, hold on. Oh, it's there, you know, but it's trying to rub off. You remember I said, look to the left of log, look to the right of log, you're going to see LN. I think that is LN.
Yes, sir.
Right, press that button. Press LN and then press shift and press it one more time.
But you have E right there. Oh, yeah.
Yeah, the keys above it. So press LN, press shift, and press LN one more time, and press equal until to get Courage.
Syntax error.
Oh, I know why. Yeah, that's fine. Erase it, clear the calculator, try it again. And this time, when you press shift and press LN, tell me what comes up on the calculator. If E comes up with an open bracket.
No, it's just E.
E, all right, press 1 now. Press the number 1.
1.
Yeah.
Oh yeah, 1.
And then press equal.
Yeah, it gives me 1.
You get the 1 now?
Yes, sir.
All right. So let me translate what you just did a while ago. So when you press ln, the natural logarithm, that's what ln is, the natural logarithm, and you press shift and you press E, you're going to get E, ln E, but you now have to tell the calculator ln E to what?
Okay.
So you want ln E to the first power because ln E to the first power is E. So you have to press ln E to the first power, and which is really E, but this is how the calculator is going to read it. And that's where you're going to end up with your 1. So Tariq, leave our Game Boy alone, it worked.
Yes, it worked.
All right.
My calculator
nice.
over here giving me some wrong answers. So.
Yeah. No, trust me, man. Is it a Casio Courage?
Sir? No.
What brand is it?
So it doesn't have, I don't know the brand.
Okay,
it's just
say
the body.
Say nothing more. Say nothing more. I don't want to say nothing more. All right, thanks, guys. All right. Okay. One last dege one. All right. Yes, this one is good. And then all right, so Joe, you will do the same thing like what Courage would have done with hers. Ellen, shift ln and then press 1 and then equal, and you should get it. So we just sending pictures of calculator. They now follow up on another class, lady. All right. All right. Ready? Watch it, them gone sleep on me now, Jesus. All right, guys. I beg you 10 more minutes. 10 more minutes and I'm done. 10 more
here,
minutes.
sir.
Okay, 10 more minutes. 10 more minutes. This wicked
Okay,
teacher,
sir.
Yes, honorable, please.
Remember the topic for the final, we were supposed to go over something. I don't know if I missed a class there. In a limit to something. When we did limit, the final thing that you were supposed to
L'Hopital's rule? I did say it earlier. So that's what I wanted to look at. So somebody read this one and tell me the answer quick and fast. The integral of e to the 7x is?
1/7.
1/7 e7x plus c.
Good job. All right, nice. All right, done. Topic done. I'm not even going to rush through the substitution method. I'm going to leave. I just have the substitution method on this document to look at. I'm not going to look at that now because I don't want to rush through it. And let me just do the L'Hopital's and then let me do the L'Hopital's and then we'll call it. Oh Lord. Let me do the L'Hopital's and call it a day or a night. You guys have done well. I don't want to abuse it. Next time I go calling for class and then I say now come to class because so me don't want. No, so I'm not going to class with I'm not coming to class with them. All right, let me just do L'Hopital's. We'll call it a day. So you know that on Thursday I'm going to have 2 things to look at. And of course, 2 things and any little other thing to brush upon it. We're going to brush upon it. All right. All right. So L'Hopital's rule. It's not hospital.
And a L rule.
Well, if you want to call it the L rule, that's fine. But it's pronounced L'Hopital's, right? So L'Hopital's rule. So in Unit 1, we were introduced to the concept of limits and the indeterminate form. What exactly is the value of 0 over 0, or negative infinity over negative infinity, or even more so, positive infinity over positive infinity, right? So those are the forms that Sir introduced it to, and we call those the indeterminate form. Is there another way that we could evaluate the indeterminate? Well, L'Hopital's rule is the way that we're going to be using evaluating these limits. It does not directly evaluate limits, but only simplifies evaluation if used appropriately. So we're going to be using the formulation limit as x tends to a of f of x over g of x. This would be the question. The first piece is a question, the limit. Let me go back to my spotlight. It's not difficult, I promise you. Just like the first one, the topic I just did a while ago, this one is pretty easy. It's going to be the limit as x tends to a of f of x over g of x. The limit as x tends to a of f of x over g of x. That's the question. What we're going to be doing now is to find the differential of the numerator. See here, f dash of x. You understand why I couldn't do it at the time in Unit 1? Because in Unit 1, we never did differentiation. Talk truth. Somebody say yes, no?
Yes, sir.
Yeah, man, we couldn't do it. So we're doing it here now. So between the differential of between the differential of f of x, so we get f dash of x. But we are also doing the differential of g of x. And g of x is going to give us g dash of x. If we still can't evaluate it or decipher the limit of this function, then we are going to find the second derivative of the numerator and the second derivative of the denominator. And if we still can't find that, we're going to go up to the third derivative of the numerator and the third derivative of the denominator. And it goes on and on and on until we arrive at our answer. All right? That's all that there is to it. Let us look at an example. It says, evaluate the limit as x tends to infinity of x squared over e to the x using L'Hopital's rule. Rockstone. So it's say, we get the question, it's tending to infinity. We have to go and differentiate the numerator and then differentiate the denominator. But sir, the denominator has an infinite number of differentials because the differential of e to the x is e to the x. So we continue getting e to the x, e to the x, e to the x, e to the x, e to the x. But the numerator, sir, has a finite number of differentials because after a while I'm going to end up with a constant. And the differential of a constant is equals to?
Constant.
The constant itself.
Excuse me? The differential of a constant is equals to?
Zero.
Zero. Remember, it's not the differential of a constant, you know. It's the, what am I talking about? So, the differential of a constant is going to be equal to zero. It's not the limit of a constant, you know. It's the differential of a constant. Fair enough?
Yes, sir.
All right, let's go. So, when you substitute your limit into the function, x squared, infinity squared is going to be infinity, and e to the infinity is infinity. So we know it's indeterminate. We know it's indeterminate. All right, so we're going to move on. So we're going to let f of x, which is the numerator, to be equal to x squared, and g of x is the denominator to be e to the x. See, Tessa? Numerator, denominator. F of x, g of x. And then we're going to set it up. When I differentiate x squared, I'm going to get 2x, dark truth.
Yes, sir.
And when we differentiate e to the x, we get e to the x, don't?
Yes, sir.
And then when we substitute our limit into the something, we still get infinity over infinity, don't? Yeah, man. So we see here that we still have the indeterminate form. So we have to find the second derivative. That's all it is, you know. So we're going to find the second derivative now. When we differentiate 2x, we're going to get 2, don't?
2.
And then now, what is going to happen right here? The differential of e to the x is e to the x.
E to the x.
Right. So in this case, when we substitute, when we find the differential of 2x, we're going to get 2, but the differential of e to the x is still e to the x. And when you substitute infinity into the function, it comes out to infinity. So we have 2 over infinity. And 2 over infinity is going to be equals to 0. Okay, that just went right over your head.
Right over there.
Me know, right there so. Right there so. What is infinity? Give me an infinitely large number, somebody. Hmm? Give me an infinitely large number, anybody.
Trillion.
Trillion. Put 2 divided by trillion in your calculator and tell me what answer you get.
I don't get nothing, sir. I don't even know if I write that number there.
Just put 2 over one big number and tell me what you get.
1, 2, 3. Yeah.
If you have a good calculator, it's supposed to tell you like 1 number times 10 to 1 enough number.
2 times.
Well, minus, not
9 times 10 to the minus
negative
22.
Yeah, so a minus not enough number, right? It means that is 0. So you see the negative 22 is 0.0000021 zeros, and then the whole number, which is 0. So 2 over infinity is actually 0. I was actually proving to you that 2 over infinity is 0.
Okay.
All right?
Okay.
Okay, so let me give you a decent looking question now. And I'm wrapping. Let me not even give it that one, because it's the same thing. Let me give it this one here. Decent looking one. So they ask you to evaluate the limit as x tends to 4 of x squared minus 16 over x minus 4 using L'Hopital's rule. So in this case, remember we can differentiate the numerator, differentiate the denominator, eh? So when we differentiate x squared minus 16, we're going to get 2x done. And when we differentiate x minus 4, we're going to get 1 done. So when we get this now, we'll apply the limits. Just like how we apply the limits up there by substituting infinity. We're going to substitute 4. 2 times 4 is 8. 8 over 1. So the limit of this function is 8. You see how easy it is? We're just finding the limit by differentiating.
So something just...
Let me go again. Remember, when you're doing L'Hopital's rule say you have to differentiate the numerator, the denominator, substitute the limit. If it comes out to be indeterminate, you have to find the second derivative. If
So you're going to send us this one today, this copy?
Absolutely,
okay.
Absolutely, absolutely. If you don't get indeterminate, you're good to go. That's the answer. So this one, when I differentiate x squared minus 16, x squared minus 16 over x minus 4, it's going to be, when you differentiate this, you're going to have 2x over 1. 2x over 1. Right. And then when you substitute the limit into the function, what you're going to end up with now is 2 times 4 is 8, 8 over 1. So this is not indeterminate. So your answer is going to be 8. So let us check to see if what it is that we did. Normally, in our what we call it, in our limits calculation, it will get the same thing. Remember, right up here, so would have recognized that this is the difference of squares. X squared minus 16 is the difference of squares. We have x minus 4 plus x times x plus 4. So we know that when we substitute inside of here, so we're going to get indeterminate. Let's check. 4 squares is 16. 16 minus 16 is 0. And 4 minus 4 is 0. So what I could do right here, so is to, oh, come on, get off my computer screen. Oh, where is that D from? Oh, Lord, forgive me. Hold on. Oopsie daisy. Why did I decide to put anything right here? So no. Okay. So it's going to be of the indeterminate form, 0 over 0. So we know that it's indeterminate, so therefore we can go ahead and do our differentiation. So when we do, sorry, this is not L'Hopital's. This is a regular differentiation, the regular limit, sorry. Why am I talking about differentiation? This is a regular limit. I'm just proving that the answer is going to be the same thing as using the L'Hopital's rule. So this is going to be of an indeterminate form, 0 over 0. So we know that there's something in the function preventing the true limit from coming out. So what I'm going to do is to factorize the numerator. So I'm going to get x minus 4 times x plus 4. Then I recognize that the x minus 4s can cancel. So I'm going to be left with x plus 4. Anywhere in the function I see x now, I'm going to substitute 4. So 4 plus 4 is equal to 8. Does that 8 ring a bell to the 8 up top? This 8 is the same 8 as this one. Oh, then sir, if they give us a question then, and they say to you, use L'Hopital's rule. We can just use any rule, and since it's the same answer, if them say L'Hopital's rule, and you're bright enough to use the regular limits method, you're getting 0. you have to use the L'Hopital's rule. Look how L'Hopital's rule easy. One line, you know. Well, okay, if you want to call it 1, 2, 3 lines, fine. But look how much line I have to go to the other one in. So all we're doing for L'Hopital's here is just finding the differential, substituting the limit, investigating. If it works out to be indeterminate, you go back and find the second derivative of the numerator and denominator. Then you can substitute the limit. If it is still indeterminate, you can go ahead and differentiate it one more time, find the third derivative of both numerator and denominator, substitute the limit. If when you do it, you don't get indeterminate, that is going to be an answer. So your question to me is, sir, how do you know when to stop? You stop when you don't get an indeterminate form. Fair enough?
Yes, sir.
All right, guess what? I'm going to send this off. You're going to look at it. People are shutting down now. So I'm going to stop right here. Thank you for coming out. I'm going to send off this L'Hopital's rule to you now and few of the questions that we did earlier in class.
Okay, sir.
And we ask that you just...
And the rules, sir. Remember the rules.
And the rules for which one?
Sir, you have some rules for all the ones that
all of what I use in class. Yeah, all of what I use in class. All right, no problem. Otto, you say you wanted to talk to me? Privately or in class here?
Yeah, private, sir. Something I want to show you.
All right. Okay, so you have to go call me because when I send out the recording, it's going to come up in tweets. So just call me right now.
All right.
Call me right now before I drop a
Yeah.
Sir, we have class Thursday.
Yeah, you know what?
All right, sir.
Sir, I'm going to clean. That's why I'm here.
You go sleep?
Clean. It's a serious day, but all right.
What time, sir? What time Thursday? Ask from now. So
sir, sir, students, what time on Thursday you want us to meet?
6 o'clock, sir. So we can finish before 10 o'clock.
All right, 6 o'clock it is?
Yes, sir.
6 o'clock to 8 o'clock.
6 o'clock.
6 o'clock to
Yes,
8 o'clock. Because when 8 o'clock comes,
Brother Grandma, yeah, that's enough, sir.
Talk through. All right, then all the best, guys. Take care.
Okay.
Take care. Come on.